Number 4, Kenny is designing a box using the diagram shown, where each length is in centimeters. If Kenny wants the maximum height possible to allow for the box to have a volume of approximately 14 centimeters cubed, what height should Kenny make the box? All right, so when we think about this, we want to have a maximum volume here, and not a maximum volume. We want our volume to equal 14 centimeters cubed. Well, let's first start with volume. What is volume? Volume is equal to, for this, you can say base times height, or you could say length times width times your height. That's the idea that we're working with here. All right, so to solve this, then, we just need to go through and say, well, what is my length? Let's just say this is L here. We'll say this is our width, and that's our height. So volume would equal 9 minus 2h, and I'm using capital letters there, but this is a lowercase, so we'll go like that, times the width, which is 4 minus 2h, times my height is simply h. So I'm going to exchange it to the lowercase so we can see what we're doing there. That's my equation. Now, we want the volume to be approximately 14 centimeters. So approximately usually is represented by a squiggly equal sign, so that means it can just be rounded like that. Now, we could insolve, but there's going to be a problem with that, and I'll show you why. So let's first go through and say, well, I want to do algebra here and just insolve this, because this is there's only one variable here. So if I go menu 3.1, menu algebra numerical solve, I could type in this equation: 14 equals 9 minus 2h times 4 minus 2h times h. I just put all these in parentheses like that. Now, for insolve to work, if you press enter right now, it'll give you an error. The reason is you have to tell it what we're solving for. And so within the last parentheses right there, in that spot, I need to do comma h here. When I do that, it'll give me, it says that height is exactly 1. That insolve says that h equals 1. Now, we could have a problem there. I'm going to just take a quick picture of this right here. Okay, and so now here's the problem. Now, I want to go Control Doc, add a page, and this time I want to do it as a graph. Now, we learned earlier that we can also graph this by saying this is F1 here. Let me change colors. We could say this is F1 and this is F2 over here. And we could graph these, so I'll have 14. And then here for my second equation, I'll do the 9 minus, I have to use x though when you're graphing. So 9 minus 2x times 4 minus 2x times x. And if you don't put this last one in parentheses, you'll have to hit the times. Otherwise, the calculator will mess up. Now hit enter, and there's the volume function. But right now, I can't get high enough to see the other line because it's at 14. And so we need to pick a number greater than 14. I'm going to just choose 20 so I can get a good image. And so we can see here, this actually crosses 3 times. Now this is very important for the sake of insolve. Insolve only gives you one answer. It gives you the answer closest to the y-axis. So if I went menu, analyze graph, and chose intersection, that very first one from here, the closest one, will be exactly 1. Well, I thought it was going to be, but it actually was not this time. I'm going to do it again, analyze graph, intersection, and this time I want to go just to the right of that one and hit enter, and see that's the one that I wanted right there. I'll do menu, analyze graph, intersection over here, and we'll have all 3 intersections given to us. Now that I have all 3, I'll take a picture and I'm going to bring it over here and paste them here. Okay, and so now I pasted this. Now here's the deal. When I'm looking for this, I want to know the maximum height possible. So some of us might be thinking, oh, this is the maximum height there. But this is actually not a good answer. This is what we would call extraneous answer. That one is extraneous. Now, the reason why it's extraneous, and I do it in yellow because that kind of signifies, it's my color to say, hey, I'm using something that's extraneous. It's an answer, but it's not a real answer, is because this volume here, notice at this point we would have to cut off from here down. This is no longer a real answer. None of this is real because your volume can't be negative on a box like this. So that part would be extraneous, and just the same if it was over on this left side. You can't get outside of the first quadrant when you do real world. Or I should say 95% of the time, real world problems will only be dealing with the first quadrant where your x's and y's are positive. So I'm looking between these two. Which x has a larger answer? The correct answer would be here. That would be the maximum. And this right here would be the minimum height possible. So because this says the maximum, my answer is, in fact, 1. But I do want to point out that InSolve only gave one answer, and this time it happened to be correct. But if it wanted the minimum, it would have been incorrect.